All right, today we're working on chapter 3. We're going to start with families of graphs. And we're going to start with section 3.2, which is just starting about talking about like what are the basics of graphing. We're looking at really the big picture. By the end of this, I hope that you can identify parent graphs for a variety of functions. I hope that you can apply transformation rules to a parent function and then graph a function using the transformation rules. So let's talk about some parent functions. The first parent function we're going to talk about is to the first power here. So we're talking here of y equals x. This is a linear equation. It just says identity function. Identity because it's to the first power. Anything to the first power is considered the identity. A lot of times the way you see this written, or you've seen it in the past, written is y equals mx plus b. And the graph of that is just this straight line, and I kind of, my line is off a little, I'm going to move it a little bit here, along our diagonal. And so with this, it's a one-to-one, it's identity, meaning it's a one-to-one ratio. And now we're going to look at the quadratic function. So we had the first degree equation, now this is second degree equation. This is, the shape of the graph is a parabola. And we did a lot of parabolas in Algebra 2, so hopefully you're a little familiar with parabolas. The way it looks is just kind of the smiley face is really what we're looking for, this curve. It's symmetric, has linear symmetry. It's symmetric according to the y-axis. This has rotational symmetry in that we could flip it all the way around. Here, I don't know if I could, I have that on there. Sorry, guys. We could flip it all the way around this. Oh, I can't do it here. We'll be fine. And it would still be the same picture. So I can kind of flip it all around. Now we're going to look here at the cubic. So we have a cubic and it's to the third power. This one actually looks like that. All right, so it's just this kind of curvy line here, and usually like this is called a point of inflection. Here, sorry, I'm going to take this one away here if I can. Go back to this one. I like that one better, I guess. So we have our point of inflection here. I'm going to kind of highlight the point of inflection. I'll come back and highlight that in a bit. But the point of inflection is this point right here at the middle that, kind of shows the point where it kind of turns, a curve turns. So now here in a cubic, oh, and I guess I forgot to do this. In a cubic here, -2 squared is +4. 1 squared was 1, 0 squared is 0, 1, and 4. So it's always going to be positive answers. Even when you square a negative number, you get a positive answer. Here, though, when you cube a negative number, you still can get a negative answer. So we have -8, -1, 0, and then 1, and then +8. So you can go way, way, way negative, and it goes negative very quickly, and then it goes positive very quickly. So we kind of have both of those. In the square root function, it actually looks like this. It kind of makes this curve and it goes off to the right usually. So at -2, it doesn't exist. You can't take the square root of a negative number. -1, it doesn't exist. At 0, the square root of 0 is 1. Square root of 1 is 1. And then we have here square root of 2 is square root of 2. And when x is 2. When x is 4, our answer would be 2. So we know if we're here, this is probably the point around 4, 2. So we kind of can guess, how it's going to curve, and that kind of helps me a little bit to know how it's going to curve. Next section. All right, so when we have absolute value, hopefully you remember this from first semester. It's our v. I really want you to think in your head that we have our v. So even when you have a negative, it's going to be a positive. And we have a positive, it's still positive. With our greatest integer function, this is also known as our step function. So I think if I said, oh, step function, you'd be like, oh, I know exactly what to do. A greatest integer function, I don't know if that would be as quick to remind yourself that you kind of make these little steps. And I'm exaggerating here, but it really does go to show just kind of how these steps look. So with our greatest integer, this is actually should be like -2.1, -1.4, 5, 0.9. So we should have actually put these as decimals here to show that here, if you're at 0.5, your answer is still going to be down to 0. here, or this would be down to 0. This would be down to -1. This would be down to -2. And this would 1, and this is back to 2. So even if you're a little bit above that, you kind of keep going back down to the nearest value below. On the rational function, where you have a variable in your denominator, when you have this -2 in the denominator, the answer is just -1/2. When -1 is in there, it's -1 divided by -1, which is -1. Now when you have 0 here in the denominator, it's 1 divided by 0, and that's not possible. So you don't have anything when you're at 0. Here it'd be 1, and this would be a positive 1/2 here. So the way this one looks is it actually does this. It kind of has this 2 curves here. And actually what's more important about this one is not necessarily, I mean, it's important to have the curves, but you might notice there's a vertical asymptote here and a horizontal asymptote. Now the vertical and the horizontal asymptote means it's approaching that value, that line, but it never crosses that line. So this curved line, the blue line, approaches the green lines, but it's never going to cross it. So when we're going to be changing this, when we're doing a transformation of this particular one, we're actually going to be transforming first your asymptotes, and then that'll help us to know, like say if we move our asymptotes, or we have like going to the right through 2 and up 4. Then it'll tell us, oh, that means then these go to the right 2 and up 4 as well. And so we're going to be doing some different transformations, excuse me. But now since we're going to be just looking at, let's go put this back where it belongs here. We're looking at the parent graph, so that's what our parent graph looks like, right about there. Perfect. All right. So I started talking a little bit about transformations. Let's talk a little bit more about transformations. Stretches, so one thing is dilations, okay? So you can have dilations. I think I skipped one here, excuse me. Let's talk about first translations. How do you go up or down, left or right, and then how do you do what's called a reflection or a dilation? So up or down. What that is shown for is we have our equation, f of x equals, I'm going to call it a, and then we'll put in parentheses here. We'll do it like this. X plus k, what do we have? All right, so we kind of have this general look of saying that a function, we could put a value out in front of a grouping symbol, and this is really, these can be any grouping symbol, and then we have x minus an h, and then plus a k. To have it go up and down, what we're looking at here is our k, all right? Something added or subtracted to outside the parentheses. So added or subtracted outside parentheses, all right? Outside grouping symbols that we're working with. Then when we're looking here, we have the same formula that we're looking at, equals ax minus h, and something can happen to those grouping symbols, plus k. And what we're looking at here is that what's ever being added or subtracted to our x inside our grouping symbols. So this again is, is going to be added or subtracted, but this one is inside the grouping symbols. All right. And if you notice, it's opposite. So that's going to be really important to remind ourselves, is it's opposite of whatever you have in there. Opposite, if it's a positive, it's a negative, it's a negative, it's a positive. So opposite sign that we're dealing with there. Reflection dilation. What we're dealing with here is, first of all, the reflection part is whether you have plus or minus in front of the a. If you have a negative, x minus h plus k, sorry. Right here, so if you have a negative here, sorry. So a negative kind of makes it upside down. Okay? So that is what we do with our reflection. It's called a reflection, kind of how we flip it, and we'll show you that in a minute. Dilation, which is kind of, we use for dilation, we call it a vertical stretch or a smash is usually what we say. Stretch and or smash, kind of push down. So we have this vertical stretch or smash, and that is our A, all right? So that's our A. Let's talk a little bit more about that, like how we can kind of change that around here with that stretch or smash. So when your A is the absolute value of a. So just whatever the a is, when it's not a fraction, when it's greater than 1, the graph is going to stretch. If it's between 0 and 1, in other words, it's a fraction, it's kind of shrunken, or it's pushed down. And it's hard, but inside the parentheses are going to affect the x values. It's going to be left or right, all right? And that's our left or right. All right, outside the parentheses affects our y values. That's our up or down. Okay, so we need to look at some equations and say, how can we move it around? So let's look at a couple equations. One I want to start by looking at is the equation y, or f of x, equals x to the third. So this is how our equation looks, like this. And we talked about our point of inflection before. So there's our point of inflection. All right, so all together, if I want to move this up or down or left or right, actually what I want to move is just that, up or down. Oh, I got everything with it, don't I? I don't want that. Oh, let's see if I can do this here. I don't know. Oh, we'll see. Oh, I'm having trouble. Okay. There we go. Up or down or left or right. Let's talk about that. So let's say if I want to move this curved line, let me try this again. Here. Let's say I want to move my curved line. I'm going to try to do one curved line for me. All right. And here's my curved line. And if I want to move it just down, this particular line, I want to go down 3. So instead of starting here at 0, 0, I want it to have that point of inflection at 0, -3. All right. What I would do to do that is I could go here, -3, and that moved it just down 3. What if I wanted to go more than just down 3? What if I wanted to go down 3 and right, let's say 4, okay? So here, I had to go down 3 and right 4. The way I would do that is I'd rewrite this, and I could write y equals, for the right 4, I actually go -4 inside the parentheses here, and then the down 3, I can go -3. So that here, this part, was the right 4. Remember, it's opposite inside my parentheses, and this was actually representing my down 3. Now, let's talk about if we have an equation like this. Y equals the absolute value of x. Well, now the equation there goes like this, okay? What if I wanted to flip it? What if I wanted it to be upside down? So I want it to be like this instead, going down. How do I do that? Well, this would be the equation. Instead of having just a positive, and this is almost like kind of saying a positive one here, sorry, in front of it, in front of my x, I would want to change it here to a -1. And the quickest way is just make it a negative. You could say it's a -1, or you can just have in there the negative, okay? So that right there makes it, this little negative makes it upside down, okay? Now let's talk about a vertical stretch or a vertical smash, all right? A lot of it's a lot like slope. It has a lot to do with slope. Let's do y equals the square root of x. All right. We know that 4, 2 is one of your equations. All right. We know it looks kind of like this. That's what it looks like. All right. What I want to do is I want to kind of morph this. All right. And if I want to morph it, and instead of going here, I want it to go way up high and over like this. So I kind of want to stretch it up. The way that I do that is I'd write this equation with a number out in front of it. Let's say that should be about a 4. Okay? So that's how I can kind of morph it up. What if instead I said, nope, I kind of want it to be smaller. I want it to be down here. I want it to be smashed down. This would be the equation y equals 1/2 square root of x. So it was always about here, what's in front of it. So this value either kind of smashes our equations down, our graphs down, or stretches them up. Notice how both times it was smashing and stretching along a vertical kind of place. So stretching up high and down low, smashing kind of toward each other when it was a fraction, smashing, like pushing it down there, okay? Let's look at some examples of this. So here it says, describe the transformation. With this one, this negative is simply, it's just going upside down. So where the parent function would be like this, all right, it's just kind of rotating that parent function, and I'm going to get rid of that, and it would just be kind of the opposite or upside down. So if I flip that upside down, I'd have